Hai, Assalamualaikum and salam sejahtera. In this video, we will talk about the electrolytic cell, but we will focus first on the electrolysis of molten compound. So I will be using the same example as in the textbook. Okay, so let's start. Okay, now let's look at the definition of the electrolysis first before we discuss about the electrolysis of molten lead to bromide. So the definition of electrolysis is a process whereby compounds in the molten state or an aqueous solution decompose into their constituent element by passing electricity through them. So there is certain words there that I need to explain first. Okay, the first one is the molten or an aqueous solution. So you have to differentiate between molten and aqueous solution. So what is the difference between molten and aqueous solution? Let me give an example. For let's say, if you have sodium chloride, okay, sodium chloride, if I heat sodium chloride until it turns into liquid, it melts into liquid. So this liquid, we call it as molten. Means you have to heat the substance in order for them to become molten. That's why if you look at the setup of apparatus just now, we need to heat the substance. But if we have the same compound and we add water, okay, we add water into the sodium chloride, it will turn into an aqueous solution. Okay, if the substance labeled as aqueous solution, AQ means aqueous, L means liquid. So if sodium chloride is labeled as AQ, it means it have water in it. So this become aqueous solution. So the difference between liquid and aqueous is liquid does not have water, aqueous have water in the substance. Although it is the same compound. Sodium chloride ni adalah benda yang sama. Okay, so now the second thing that I want to explain is the constituent element. What does it mean by constituent element? Constituent element is the element that exists in a compound. For example, if we are using lead bromide, so lead bromide is a compound, consists of lead and bromine. So the constituent element in lead to bromide is lead and bromine. That is the meaning of the constituent element. So if I say, what is the constituent element for sodium chloride? Just now. Okay, what is the constituent element for sodium chloride? The constituent element for sodium chloride is sodium as in atom and chlorine as in molecule. Okay, why molecule? Because chlorine cannot exist as atom in the room temperature. It always exists as diatomic molecule. So sebab tu constituent element dia adalah chlorine molecule. So what electrolysis do is, electrolysis will separate the compound to its constituent element. But you have to have electricity. Electricity must pass through them. Okay, kena ada elektrik baru dia boleh kembali balik kepada elemen dia yang asal. This is what we are going to learn in this subtopic on electrolytic cell. So now let's look at the electrolysis of molten lead bromide. So this is a very simple electrolysis that we are going to discuss here. The first thing that you have to do is you have to write down the equation for the compound. So lead bromide, okay, when it ionizes, why does this compound ionize? Because you heat the compound so that it turns into liquid. When we heat the lead to bromide until it change to molten, okay, daripada keadaan solid, so as solid it change to liquid, so it will ionize. So what happen if the compound ionize? It will form Pb2 plus ion and bromide ion. Okay, why I write 2Br minus? Because if you look at the formula here, there is 2 bromine atom there inside the formula. So you have to write 2 bromide ion. So this is the cation. Cation is a positive ion, okay, and an ion in the compound. Okay, so cation is the positive ion, anion is the negative ion. As we already learned in our previous video, if you watch my video, okay, the cation will be attracted to cathode. Okay, always cation attracted to cathode. Anion will attracted to anode. So N dengan N, cat dengan cat. Cation tertarik kepada cathode, anion tertarik kepada anode. Okay, what happened is, if we complete the circuit, means we already switch the switch on in the circuit, and we have the batteries. So we have the cathode and the anode. Which one is cathode? Which one is anode? Cathode is the shorter version of the line. So that one is cathode. Okay, anode is the longer version of the line. Cathode is actually the negative terminal of the battery, negative terminal of the battery, and the anode is the positive terminal of a battery. Anode is the longer line in the cell. So what happened? We pass through an electricity through the circuit, and after we heat the lead bromide will become ion, and it will dissociate ataupun ia akan ionize inside this circuit. So Pb2 plus will attracted to cathode. So this is cathode. So the Pb2 plus will go here, Pb2 plus, and the anode, the anion will attracted to the anode, bromide ion. Not only one ion, means lot of ion. All the ion that exists in the molten lead to bromide, all the Pb2 plus will attracted to the cathode, and ion will attracted to the anode. So what happened next? Of course, this is a redox reaction. Okay, so an oxidation and a reduction reaction will happen. The question is, which one, which ion will undergo oxidation and which ion will undergo reduction reaction? So if you look at the cation and the anion here, you have to decide which ion will undergo oxidation, which ion will undergo reduction. As you already learned before, lead 2 plus ion is a positive ion. Can a positive ion release electron? Of course, no. Positive ion always accept electron. The only ion that can release electron in this cell is bromide ion, because bromide ion already have negative electron. It cannot accept more electron. The bromide ion can only release electron. It cannot accept any electron because the ion already achieved the stable octet electron arrangement. So if you look at bromide ion here, so Br minus, so this ion cannot accept electron. Why cannot accept electron? So you already learned in the chemical bond during your form 4, bromine atom have an electron arrangement of 2, 8, 18, 7. So this is bromine atom. So what does it mean by bromide ion? Bromide ion is when bromine atom accept electron to form bromide ion. So this is Br minus ion. Your electron arrangement will be 2, 8, 18, 8. So this bromide ion cannot accept any electron, okay, because the ion already achieved stable octet electron arrangement. Bromide ion can only release the electron that being accepted by the atom before this, okay, before the formation of the lead bromide. So what we can do, we can write the half equation for the oxidation reaction where the bromide ion will release electron to form bromine, but bromine cannot exist as atom. It always exists as bromine molecule. So that's why we will write down the bromine as a molecule. So Br2, and then you will release 2 electron. So this is why the half equation for bromide ion will be 2Br minus, produce 2 electron and 1 bromine molecule. So this is molecule coming from the ion. Is this an oxidation reaction or reduction reaction? If you look at the half equation, you can see that the ion release electron. So if the arrow comes first, this means release. The bromide ion release electron to form bromine molecule. So this is oxidation reaction. Okay, oxidation reaction can also be recognized from the change in oxidation number. The oxidation number for bromine here is -1 because it is bromide ion. It changed to molecule. So molecule, the oxidation number becomes 0. So this increasing oxidation number from -1 to 0 is oxidation reaction. So remember, if you have an increasing oxidation number, increase in oxidation number, it is an oxidation reaction. Okay, ada dua benda lah cara untuk you recognize. Satu, release of electron. So this is electron release. Okay, the second one is the change in oxidation number. So the change in oxidation number, because in this case, the oxidation number increase. Okay, the oxidation number increase means oxidation reaction, or you can always remember oil. Oxidation is loss of electron. Oxidation is loss of electron. Okay, so now let's look at the cell just now. The bromide ion release electron, right? So I write down the half equation here. Bromide form bromine molecule and release 2 electron. These 2 electron coming from the bromide ion, it will transfer from the anode to the cathode. The electron will move to the cathode. Okay, after that, the bromine molecule exists as gas. So this will turn into gas because it exists as molecule. Molecule for bromine will exist as gas. So you can see there will be a brown vapor produced during the reaction. So when the electron reach cathode, there must be an ion that accept the electron released by the bromide ion. So who will release the electron? Which ion will release electron? The only ion that exists in the molten lead-2 bromide is lead-2 plus ion. So this is the only ion that can accept the electron, and of course the positive ion can accept electron. So what happened at the cathode is the cation, the Pb2 plus, will accept the electron and form lead atom. Okay, so this is ion, this is atom. Okay, why it form atom? Because it accept the electron that being released before this and form its atom again. So during this reaction, as you can see, ada accepting of electron, the gain of electron. So if you gain electron, it is a reduction reaction. So this reaction is a reduction reaction. If you want to explain in terms of change in oxidation number, you can see that the oxidation number changed from +2 to 0. Okay, the oxidation number for an atom is 0. So the change in oxidation number, as you can see, the oxidation number decrease. So we can say that this is a reduction reaction. And if you want to explain in terms of gain of electron, so this is gain of electron. Okay, so again, just remember reduction is gain of electron. So this is a reduction reaction. What happened at the cathode? The Pb2 plus will accept electron to form lead as in atom. So when lead atom form, you will see grey solid deposited at the cathode. And some of the lead will be collected at the bottom of the crucible because it's quite heavy compared to the liquid. There will be lead atom, and the lead atom color is grey solid. So you can see that grey solid deposited. For the bromine, you can see bromine exists as brown gas, so brown gas produced. For a conclusion, in an electrolytic cell of a molten compound, you only have 2 ion, one cation and one anion. So the cation will attracted to cathode and anion will attracted to anode. So this is the half equation that we can see at the cathode, and this is the half equation that you will see at the anode. You'll write down the half equation. So bromide ion will release 2 electrons to form bromine molecule. It is an oxidation reaction. Okay, you can explain in terms of electron that released during the reaction or change in oxidation number. Okay, at the cathode, the lead-2 plus ion will accept electron to form lead atom. Okay, there is a gain of electron and change in oxidation number. The oxidation number will decrease. In the next video, I will explain about the electrolytic cell for an aqueous solution. So there will be 3 factors that affect the ion that will be discharged at the cathode and the anode. So we'll discuss in the next video. Okay, so thank you.